Hello students, you are welcome once again to Prep Class Tutors. My name is Mr. Chima, your Prep Class Tutor on chemistry. So today students, we are going to be solving past questions on JAMB for the year 2020. Alright, so students, how is it going? What's happening? How have you been seeing our videos? Or should I say, how do you see our videos? Have our videos been very helpful to you? Especially those of you that might find or see the kind of dread to solve calculations under chemistry. Have our videos been very useful? We would like to know how helpful our videos are to you. Have they been very useful in helping you to tackle all those questions which you'll be finding challenging previously before you join Prep Class Tutors? Now, that is why we will always like you to subscribe to our YouTube channel so that you can be getting more and more fantastic videos like this. Like our YouTube channel so that you can be getting updates on what more videos that can be very helpful for you in destroying all those challenges that you find maybe in JAMB or WAEC or any other examination body. Now, if you look below the subscription button there, you will see our comment section box. So try to drop your comments on what you think about our video. Please do not forget to share our videos. Remember that there are many students that are looking for this same opportunity which you are enjoying with Prep Class Tutors. So please try as much as possible to share our videos so that they can reach as much students as possible. Okay, so having said that, today we are going straight to look at past questions on JAMB for the year 2020 on chemistry. Now, in our previous videos, we have tackled and destroyed even those ones that have calculations, questions number 1 to 15. So quickly, Mr. Chima is going to be driving you through questions 16 to 20 in today's section with Prep Class. So quickly, let us go. Question number 16. Look at the equation of reaction above. 2Cl2 gas plus 2H2O gas, delta H is positive. Kind of reaction, though it's not properly written, they didn't write it very well, but we just decided to place it this way so that this is the way it is being written in the past question, so that we will not alter the originality of the question. But since it looks it's not well written, maybe that is their own cup of tea, that's their business. Now, what you must know is that because in this kind of reaction, and they're asking you equilibrium, it's an equilibrium reaction, there's supposed to be a two-sided arrow, whereby one is pointing forward, the other one is pointing backward. Sorry, let me use a pointer. There's supposed to be two-sided arrow, where one is pointing forward to the product, one is pointing backward to the reactant, but they didn't show that kind of thing. But let us just consider this delta H. When delta H is positive, the rate of reaction, or should I say that the forward reaction, will always be favored. So no matter how they write the reaction, that is their own cup of tea. Just know that since delta H is positive, you have plus 15 kilojoule per mole. Since delta H is positive, that simply means that the reaction is what? Endothermic. You can see here, since delta H is positive, that is an endothermic reaction, and increase in temperature before the forward reaction. So that's what I just want you to note, that since delta H is positive, increase in temperature will favor the forward reaction. Because since delta H is positive, it means that this reaction is an endothermic reaction. If delta H is negative, it's an exothermic reaction. So for an endothermic reaction, where delta H is positive, increase in temperature will favor the forward reaction. But if it's an endothermic, it is an exothermic reaction, where delta H is negative, increase in temperature will favor the backward reaction. So for an endothermic reaction, increase in temperature will always favor the forward reaction. So the answer is that the forward reaction will be favored. So favor the forward reaction is the correct answer. B. Number 17. A filter paper soaked in lead ethanoate solution will turn black in the presence of, is it hydrogen chloride, sulfur 4 oxide, hydrogen sulfide, sulfur 6 oxide gas. Now look at what I said here. I said that this is a test for hydrogen sulfide. Sulfide will turn lead ethanoate or lead triisonitrate 5 into black lead 2 sulfide. So if I should soak a white filter paper inside lead ethanoate, or I soak the same white filter paper inside lead triisonitrate 5, any of them, and I pass it over hydrogen sulfide, this filter paper is going to turn black, and that black color is due to lead 2 sulfide. So hydrogen sulfide usually change lead 2 ethanoate and lead 2 triisonitrate 5 to what? Lead 2 sulfide. So this is a basic test for hydrogen sulfide. So the answer is hydrogen sulfide gas. Take note of that. Hydrogen sulfide turns lead ethanoate or lead 2 triisonitrate 5 to black lead 2 sulfide, and that is a what? Test for what? Hydrogen sulfide gas. Alright. Question number 18. Which of the following is an aromatic compound? Which of the following is an aromatic compound? Now if you look at them critically, this one is an ethanol, this one is an alkyl halide, this one is an alkane, C6H5OH. That simply means that this OH is displacing one hydrogen ion. And we know that 6,6H6 is benzene, and benzene is aromatic. Look at what I said here. I said that aromatic compounds are those organic compounds that are similar in structure to benzene. They are cyclo in nature, and they have, you can see the cyclo nature with double bond here, double bond here, double. So it's either you draw it this way, double bond here, double bond here, or double bond here, double, or you just draw the cyclo nature and put a circle. That means you can draw it this way and put a circle at the center. So aromatic compounds are those organic compounds that are similar in structure to benzene, C6H6. So, and I said that option D, C6H5OH, is phenol. It is aromatic. So the name of this compound, C6H5OH, is actually what? Phenol. Phenol is the name of this compound. And because it is phenol, you can see the structure. This is benzene. This is phenol. C6H5OH. This is phenol. You can draw it this way or this way. It is phenol. So because it is similar in structure to benzene, it is an aromatic compound. So the correct answer is C6H5OH, which is what? Phenol. Question number 19. One of the methods used to convert hard water to soft water is? One of the methods used to convert hard water to soft water is? A. Is it the use of an ion exchange resin? B. Is it passage over activated charcoal? C. Is it chlorination? D. Is it aeration? Now look at what I said here. I said hardness of water is caused by soluble tetraoxosulfates of calcium and magnesium. That is CSO4 and MgSO4. Now you must note that this kind of hardness that is caused by CSO4 and MgSO4 is known as permanent hardness. Temporary hardness is caused by calcium hydrogen triisocarbonate 4. Temporary hardness is caused by calcium hydrogen triisocarbonate 4. That is CaHCO3. And that one can be easily be removed by boiling, because if you boil that water, the calcium hydrogen triisocarbonate 4 will decompose and break to release calcium triisocarbonate 4, which will now come out as a precipitate. Then that means the hardness is being removed. But this CSO4 and MgSO4, it may not be able to decompose. It does not decompose on heating, so it is stable. So because of that, they cause permanent hardness of water, and it cannot be removed by boiling. So the only way we can use in removing it is by either using a chemical substance. One of the most common one we use is washing soda, that is sodium triisocarbonate for Na2CO3. So we treat the water with Na2CO3. The Na2CO3 will remove the CSO4, because the Na2CO3 will now become NaSO4, and the Ca will now become CaCO3, which will come out as precipitate. Are you following? Thereby removing that hardness. So is that you treat it with washing soda, or you pass it over an ion exchange column. In that ion exchange column, the sodium ions will be exchanged with the calcium and magnesium ions that causes that what? Hardness. Are you following? So we call that. So since we don't have treating with washing soda in the option, what we have is ion exchange resin. So the correct answer is what? Ion exchange resin. So it's either you use this or pass it over an ion exchange column where the sodium ions will replace the calcium or the magnesium ion. So your correct answer is what? A, the use of an ion exchange resin. Question number 20 and the last for today. The quantity of electricity that will liberate 0.125 mole of oxygen molecules during the electrolysis of dilute sodium chloride solution is now this is electrolysis of dilute sodium chloride solution. You must know that in dilute sodium chloride solution we have NaCl and water, but the water molecules are more than the NaCl. Maybe in a big bucket of water they put like maybe 2 pinch of salt. That's the dilute sodium chloride solution. So the water molecules are more than the sodium chloride. Now the sodium chloride will dissociate towards sodium and chloride ion. The water molecule will dissociate to hydrogen and hydroxide ion. So you can see that the ions we have here are sodium and hydrogen, which are the cations, and chlorine and oxygen, which are the anions. Now there is what we call preferential discharge, factors that causes preferential discharge of ions. We have relative position of electrochemical series, nature of the electrodes, and concentration of ions. Those are the properties or the factors rather that tells you what kind of ion will be given out during what electrolysis. Now in this case, remember that sodium will not go out because there is hydrogen, and also between the anions chlorine and OH minus. OH minus is more in concentration. There are more OH minus because of there are more water molecules. There are more OH minus than chlorine. So OH minus will go to the anode and hydrogen will migrate to the cathode. So in the electrolysis of dilute sodium chloride, hydrogen ions will migrate to the cathode and be displaced as hydrogen gas, while OH minus will migrate to the anode and be displaced as oxygen gas. Now look at the equation for the displace of OH minus as oxygen gas at the anode. So that's 4 OH minus after you balance the equation to give you 2H2O liquid plus O2 gas plus 4 electron. This is the complete equation. This is the way it is. The OH minus dissociate to water and oxygen, giving out 4 electrons. So because it gives out 4 electrons, that 4 electrons translate to 4 Faraday. Remember, if it is a metal that is being displaced, a metal will absorb it and become displaced as atom. Now, if it's a metal that is being displaced, if it's a univalent metal, let's say like silver that is Ag+, it will be 1 Faraday. If it's divalent like Ca2+, that's calcium ion, Ca2+, are you following? It will become 2 Faraday. But for an anion, this one, since it will use the electrons, so since 4OH minus decompose to give this 4E minus becomes 4 Faradays. That's why I place 4F here. And they said there's 0.125 moles. That's the amount of the substance oxygen that is given up. So that's why I place 0.125 moles. I like using this formula, and because EIT over farad, I like it because once you apply it to electrolysis, you get the answer. N is the mass of the substance deposited. E is the molar mass of the substance. IT, I is current, T is time. So current times time is quantity of electricity. Q is IT, and F is the Faraday. So from here, if you make, because they're asking you the quantity of electricity, that is, they're asking you the quantity of electricity, which is Q, and that Q is this IT here. Q is IT, quantity of electricity is IT, I is current, T is time. Quantity of electricity is current times time. So if you make IT here the subject of formula, you have MF over E. Do you understand? How do you make IT sort of formula? Cross multiply, this will become M times F, divide both sides by E, you have MF over E. So IT becomes MF over E. I've made IT the sort of formula. That is, IT now becomes M over E, mass over molar mass, times 4 Faraday. 4 Faraday because oxygen is being dissociated with 4 electrons. That's why it is 4 Faraday. So remember I said that this IT means Q. Q is equals to IT. That's quantity of what? Electricity. So Q now becomes M over E times 4 Faraday. So replacing this IT with Q. So Q becomes M over E times 4 Faraday. Remember that mass over molar mass is what? Number of moles. Because I said that where E is the molar mass and M represents the mass. So number of moles equals mass over molar mass. So that means that therefore the number of moles N becomes M over E, mass over molar mass. And they've given us a number of moles as what? 0.125 moles. 0.125 moles. So now that simply means I'll change this M over E, which is mass over molar mass, to number of moles. So that becomes Q becomes M, which is M over E, times 4 Faraday. I believe you understand that. So my Q now becomes, what is my N? 0.125 moles times 4 times Faraday. 1 Faraday is what? They've given us 96500 coulombs. That is 1 Faraday. Where is it? Let's go back to the question. F equals 96500 coulombs. This should be coulombs. They don't know what's their problem there. So that's Q becomes number of moles times 4 times 96500. So when you multiply 0.125 by 4, then by 96500, you have 48,250 coulombs. So that's your quantity of electricity. And of course, this is it, option C, 48,250 coulombs of electricity. Very simple. So alright, students, we've come to the end of today's section on chemistry with prep class, where we solve past questions from question 16 to 20. So below here, you see a link. You use this link to join our WhatsApp group. And when you do so, you'll be having updates on the current videos which we have for you available on YouTube. So till we meet again, my name remains Mr. Chima, your prep class tutor on chemistry. Bye and stay safe.